Welcome to the session on algebraic expressions, rationalizing the denominator. The objectives for this session are to make the denominator of a fraction rational using the formulas shown on your screen or otherwise. For a fraction with a surd in the denominator, it is sometimes useful to rearrange the fraction so that the denominator is irrational. This process is called rationalizing the denominator. Let's take a look at some examples. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at part A first. We are required to rationalise the denominator of 1 over root 2. In order to do this, we multiply by root 2 over root 2, which is of course equal to 1. What this also does is make the denominator rational. So of course the numerator is 1 times root 2, which is root 2, and the denominator is root 2 times root 2. So we have root 2 divided by 2. And therefore we've rationalised this expression. Now for part B. This is slightly more complicated. We are required to rationalise the denominator of 1 over 7 plus root 2. We're going to multiply by 7 minus root 2 over 7 minus root 2. This makes the numerator 7 minus root 2. And now for the denominator. What happens to this? We have 49 minus 7 times root 2 plus 7 times root 2 minus 2. So in the numerator we have 7 minus root 2, and in the denominator we simply have 47, since minus 7 root 2 cancels with plus 7 root 2. And so we've rationalised this expression also. And now for part C. We are required to rationalise the denominator of the expression shown on your screen. So notice the denominator, we have root 6 minus root 2. What do you think we need to multiply the numerator and the denominator by in order to make the denominator rational? We multiply by root 6 plus root 2, divided by root 6 plus root 2. So in the numerator we have root 6 plus root 2 times root 6 plus root 2, and in the denominator we have root 6 minus root 2 times root 6 plus root 2. So in the numerator, when we multiply out, we have 6 plus root 6 root 2 plus root 2 root 6 plus 2. And in the denominator we have root 6 times root 6 plus root 6 times root 2 minus root 2 times root 6 minus root 2 times root 2, to give us in the numerator 8 plus 2 root 6 root 2 divided by, and in the denominator we have 6 minus 2. And of course root 6 root 2 cancels with minus root 2 root 6. We're now going to break down the numerator so that it becomes a little bit more easy to read. In particular, we're going to change root 6 to root 3 times root 2, and hopefully you'll be able to spot that we've now got in the numerator 2 root 2's. So let's see what we can do with this. And of course we leave the rest as it is. And in the denominator, 6 minus 2 of course becomes 4. So now let's tidy up the numerator. We have 8 plus 2 root 3 times 2, all divided by 4. So we have 8, and we leave the root 3 as it is, and we multiply the 2 by the 2 as shown to give us 4, and this is of course all divided by 4. And now we can divide by the 4. So 8 divided by 4 is 2, and 4 divided by 4 is 1. So we have the expression is equal to 2 plus root 3. And now for part D. We are required to rationalise the denominator of 1 divided by 1 minus root 7 all squared. We can express this, of course, as shown on your screen. And then expanding the denominator, we have 1 minus root 7 minus root 7 plus 7. And tidying up gives us, in the numerator, 1 minus 2 root 7 plus 7. And tidying up gives us 1 divided by 8 minus 2 root 7. So now we simply need to rationalise 1 divided by 8 minus 2 root 7. We can do that by multiplying by 4 plus root 7 divided by 4 plus root 7 as shown. And so we have in the numerator 4 plus root 7, and expanding the denominator gives us 2 times 16 plus 4 root 7 minus 4 root 7 minus root 7 times root 7. And tidying up gives us 4 plus root 7 all over 2 times 16, and of course the 4 root 7 cancels with the minus 4 root 7, and we have minus 7 at the end here. And so tidying up some more gives us 4 plus root 7 divided by 18. And as you can see, we've now rationalised the denominator of the expression. We do have formulas for making the denominator of an expression rational. So 1 over root a equals root a over a. But how did we get this? Suppose we were required to rationalise the denominator of 1 over root a. Then of course we'd simply multiply by root a over root a to give us 1 times root a in the numerator and root a times root a in the denominator, which is equal to root a divided by a. We also have another formula. 1 divided by a plus root b can be expressed as a minus root b divided by a squared minus b. But how would we derive this formula? Let's have a look. If we have the expression 1 divided by a plus root b, we're going to rationalise its denominator. We need to do this by multiplying by a minus root b divided by a minus root b to give us 1 times a minus root b in the numerator and this expression here in the denominator. Expanding out in the numerator gives us 1 times a minus 1 times root b, and in the denominator we have a squared minus a root b plus a root b minus root b times root b to give us a minus root b divided by a squared minus b. And as you can see in the denominator, minus a root b has cancelled with plus a root b. And now for the third formula. How do we make this denominator rational? Or how do we find the general formula for making the denominator rational? We begin with 1 over a minus root b. And we multiply it by a plus root b divided by a plus root b to give us this expression in the numerator and this expression in the denominator. And so if we multiply out, we have 1 times a plus 1 times root b divided by a squared plus a root b minus a root b minus root b times root b to give us a plus root b all divided by a squared minus b. And so we have our three formulae. We can use them directly in order to make expressions or particular expressions rational. Let's take a look at this example. Pause the video and have a go. Press play when you're ready to view the solutions. For part A, we are required to rationalise the denominator of 1 over root 2. Clearly, we're going to use the first formula. In the expression 1 over root 2, a is equal to 2. So we substitute a equals 2 into this formula to give us root 2 divided by 2. And now for part B. We are required to rationalise 1 divided by 7 plus root 2. We're going to use the second formula as highlighted. Here, as you can see, a equals 7 and b equals 2. So we can now plug in a equals 7 and b equals 2. To give us 7 minus root 2 divided by 49 minus 2, which equals 7 minus root 2 divided by 47. And now for part C, we are required to rationalise 1 divided by 6 minus root 2. We're going to use the third formula. In the third formula, a equals 6 and b equals 2. Let's now plug in a equals 6 and b equals 2. To give us 6 plus root 2 divided by 36 minus 2. And so we have 6 plus root 2 divided by 34. This brings us to the end of this session. If you have understood its contents, you should be able to make the denominator of a fraction rational using the following formulae on your screen or otherwise. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.